So today we're going to talk about arc length. Arc length is not a brand new concept for you. You definitely talked about it in geometry, but when you did it in geometry, you for sure used degrees. You may have done some with radians, but probably not. But in that big unit of circles, that's when you talk about arc length and sector area, and then that's what gets you into radians and all that good kind of stuff. So when you learn it in geometry, I don't know how you learned it because there's different ways to teach it, but there is a big yucky formula for it. I am not a fan of the formula. I never teach the formula because nobody's ever going to remember it. Not that it's necessarily something you have to have memorized, but you can do this separately. You can set it up proportionally, and anytime you can do anything proportionally, that's the way you should do it because you understand proportions. It makes sense. If you understand the whole piece out of a whole thing, you're good to go. So let's talk about arc length in degree-wise, like you might have seen it before, and maybe you learned it proportionally as well. I don't know. So S, the little s is for arc length. So this is an arc. It's just the actual length of the arc. Why it's a lowercase s, I don't know. I've never bothered to figure it out. It seems odd, but whatever. So this is just this length of this right here. What is the length all the way around the circle called? Circumference, exactly. So arc length is just a piece of the circumference, right? It's like you're just cutting a piece of that circumference off. So the arc is always subtended by some angle here. So let's say this was an angle in degrees. The angle, whatever it is a part of the entire degrees. How many degrees in a circle? 360. And the arc length is a part of the circumference. So then when we think about radians, if this is an angle in radians, instead of being out of 360, it's out of how many radians? Close. 2 pi. Yes, good. 2 pi. So 360 degrees is 2 pi radians. So if we just set this up proportionally, and we can say we have some angle theta out of a total of 2 pi radians, piece out of the whole, that angle is related to the arc, so then I would have the arc, which is part of the circumference, right? Piece out of the whole, piece out of the whole. That's a proportion for you. So now but here's the thing, with the degrees, I really think it's easier just to leave it as a proportion and go with it that way. When we actually have radians, it actually makes it easier to use the formula. One of the reasons the formula for degrees is just worse is because within that formula, you're converting to radians because it's actually a radian concept. So let's see if we can simplify this sum. So we're going to cross multiply, and we're going to have c times theta equals 2 times pi times s. I just cross multiplied. Make sense? All right, so now I can substitute and think before you speak so the wrong thing doesn't jump out of your mouth. What is the formula for circumference? 2 pi r, good. All right, so 2 pi r. So instead of c for circumference, I'm going to put in 2 pi r. So I get 2 pi r times theta equals 2 pi times s. So if I wanted to solve for arc length, it's being multiplied by 2 pi, so I can divide this side by 2 pi, divide this side by 2 pi. Those cancel out, those cancel out, so I'm just left with r theta equals s. Can't remember the formula? Worst case scenario, make a proportion. It's definitely doable. Okay, so that pretty much is our arc length formula. I'm going to flip it around though. So it says if theta is a central angle, so central angle means the vertex is at the center of the circle. So if theta is a central angle in a circle with radius r, then the length of the intercepted arc s, this arc right here, is given by s equals r theta. The important part here is where theta is measured in radians. So if it's not in radians, I don't get to use r theta. It's fairly simple. Everybody good so far? All righty. So let's look at number 1. It says in a circle we got radius 3 feet. I'm going to change that. Radius 3 feet, an angle measuring 5 pi 6 radians. intercepts an arc. I want to find the length of the arc. So it's just a plug and chug problem. So the arc length is equal to the radius, which is 3, times the angle, which is 5 pi sixths. Now I could multiply and then reduce, but it's actually a lot easier, especially when the numbers get bigger, if you reduce first. I can put 3 over 1. 3 goes into 3 once, goes into 6 twice. So I end up with S equals 5 pi halves. And then what would the units be on this? What do you think? Feet, yeah. I mean, it kind of looks like a radian measure, but it's an arc length, and so there's feet there, it would be feet, and that's it. What questions do you have? And having a pi in it should make sense because it's a part of the 2 pi times the radius, right? So it's going to have a pi in it. All right, so let's look at number 2. In a circle, we've got a radius 22 inches, the angle measuring pi fourths radians. I want to find the length of the arc. So S equals R times theta. Pretty simple, right? What do we get for the arc length? 11 pi halves. And the units here would be inches. Okay. Everybody good so far? All right, so what if we have different information? We have in a circle, we've got an angle. Here's our angle in radians. Here's our arc length, and I want to find the radius. So I substitute in what I know. I know the arc length. It's 3 pi eighths. So that's equal to R, which I don't know, times theta, which is 3 pi halves. So I want to get R by itself. What would I do to get rid of that 3 pi halves? Multiply by the reciprocal. Beautiful. So the reciprocal of this is 2 over 3 pi. I'm going to multiply that by 3 pi over 8. That's equal to R. The 3 pi's cancel out. R is 1/4 what? Feet. Everybody good? Okay. Any questions? Got to have some fraction knowledge. All right, so number 4 says, in a circle, we have an angle measuring 15 degrees. We've got an arc length of 2 pi thirds, and I want to find the radius. All right, well, this is in degrees. My formula said I only get to use S equals R theta if it's in radians. So I could set up a proportion and do degrees, but we're just going to go ahead and convert this because I want you to think about this. There's a couple different ways we could convert 15 degrees. If you want to convert degrees to radians, what do you multiply by? It's an easy conversion back and forth. It's been a while since we did it. Do what? I'm sorry. It's a fraction, something over something, and you do the reciprocal for going the other way. Pi over 180. You're either multiplying by pi over 180 or 180 over pi. And when you want to go from degrees to radians, you have to have the pi in the numerator. So that's one option, but I'm not going to do that one this way. I could, there's nothing wrong with it, but there's actually a little bit easier way depending on what the degrees are. Like, I don't know what 15 degrees is radians, like just off the top of my head. Maybe I don't know. But I do know that 30 degrees is how many radians? Pi over 6, right? That's something you actually should know. So 15 is 30 is a multiple of 15, so that means that 15 degrees would have to be how many radians? Pi 12ths. Last period somebody said pi thirds, and then they stopped themselves. Like as soon as it came out of their mouth, they knew that they were wrong, but they divided the 6 by 2. So remember, dividing by anything is the same as multiplying by 1 over that thing. That's important. Okay, so that's my angle in radians now. So this is what I'm going to use. So blah, blah, blah. I have the arc length. It is 2 pi thirds. That's equal to the radius, which I don't know, times pi 12ths. Okay, so go ahead and finish that one up. I got 8 feet. We good? You have a question, Bianca? Giving me a weird look, which usually means you have a question. Oh, okay. Sometimes there's weird looks because you'll have trouble seeing the board, and sometimes it's total confusion, and I can't always tell. Harder to tell with the masks on. All right, we all good so far? Alrighty. Let's look at the next one. Oh, goodness, I forgot to giving myself away here. All right, so in a circle with radius 9 meters, so I've got the radius, angle intercepts, I've got the arc length of 6 pi. I want to find the angle. So arc length is 6 pi. That's equal to r, which is 9 times theta. Right? Trying to get theta by itself, so I divide, so I get 6 pi over 9 equals theta, which means theta equals 2 pi thirds, and this is radians because it's the angle. Okay. It's just substituting numbers into a formula and finding the different pieces, really. I know you could have done most of this without me saying a lot of it, but there's other little things that happen in here that I want to just cover that are like general math things. So. All right, if there's no questions on number 5, you go ahead and do number 6 on your own. So remember, like if you look at number 5, when I needed to divide, just straight up dividing worked just fine. Dividing here would give me a fraction and a fraction, which is not the end of the world. I could make it work, but it made more sense for me here to multiply by 1 over 18 instead of dividing by 18. So just keep those things in mind so you're not complicating your life. Okay. Any questions? We're all good? Okie dokie, let's look at number 7. A merry-go-round rotates 2,808 degrees per ride. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? So if you think if you're on a merry-go-round, however far you are from the center of that thing that's going around in a circle, that's creating a radius, right? And if you go around more than once, then you're going around more than 360 degrees, which is definitely what's happening here. So here, we need to convert these degrees to radians, and I can't do it the same way I did the 15 and the 30 because even if that is a multiple of something, I don't know off the top of my head, and I don't want to spend the time thinking about it. So one of the things that's very important that you have, and that some of you have very well, and some of you need to work on, but you need to actually work on it, because nobody can really force you to work on it. You have to practice it yourself, is the number sense. And So when we go through this, sure, I know you always have a calculator in your pocket because you always have your phone, but if you take AP Calculus, you're not going to get a calculator on the whole thing. Depending on what math classes you take in college, your professors may not allow it on some of that stuff. And the better, regardless, the better you are at the number sense, the easier things are to think through because the numbers just make more sense. Okay, so that's why I talk about this kind of thing so much. So we're going to convert that 2,808 to radians. So I'm going to take that 2,808 and I'm going to multiply it by pi over 180. Okay, so I'm going to reduce that without a calculator. Now, I could stand here and try and think the biggest number I could divide into both, but that's not worth my brain cells or my time either. So instead, they're both even. I'm going to make this into 90, and I'm going to make this into 1404. Because not only are they both even, they're both fairly simple to divide by 2, right? Then I'm going to do that again. So I'm going to make this 45, and I make this 702. Okay, so at this point, I have exhausted my even numberness, and there's a lot going on, so I don't want to lose myself in my work, so I'm going to rewrite this 702 pi over 45. Okay. So the numbers I could use for 45, it's the smaller ones, I can think through this. I can divide it by 9, by 5, by 3, by 15. So I know clearly 702 not divisible by 5. Is 702 divisible by 3? Yes. Is it divisible by 9? Yes. Remember, your 9 and your 3 trick are really kind of the same. So when I add 7 and 2, that gives me 9, which tells me it's divisible by 3. But because when I add these together, that number is also divisible by 9, means it's divisible by 9. So if I can divide by 9, that's great. Otherwise, I could divide by 3 and divide by 3 again. But I know that I can divide 9 into 45 and get 5. I can divide 9 into 702, so 9 goes into 70. Well, 9 times 8 is 72, so that means it will be 7 times. 7 times 9 is 63, so I have 7 left over. That gives me 72, this would be 8. So that gives me 78 pi over 5. So the only thing I have left to divide by is 5. 78 is not divisible by 5. It's reduced all the way. Okay. Now, I'm not saying you have to do it that way. I know some of you can look at numbers and you see the big numbers already. Great. Knock yourself out. Most people aren't looking at numbers like that. So that's a gift that you have. Cherish it. But I've reduced it all the way. Okay. So just be patient. And honestly, this usually goes a little faster than you trying to figure out numbers anyway. Okay. All right. So now we have our angle. This is what we're going to use. And so I've got my angle, 8 feet from the center. That's my radius. How far would they travel? That's going to be my arc length. So my arc length is how far I travel around the circle. That's equal to my radius, which is 8, times theta, which is 78 pi over 5. Now, unfortunately, the 8 and the 5 don't reduce. So a couple of different ways that you could attack this 8 times 78. I could do 8 times 80. What is 8 times 80? 640. So I got 640, but I know that's too much. If I get 640, how much would I have to subtract? 16, because that extra 2 times 8 minus 16. So I could do it that way. Another way you could do it is 8 times 70. So that's going to be 560, and then 8 times 8 is 64, and then you could add them. Either way, you're going to get the same number, or you could multiply old school and carry and whatever. That's fine. But I get 624 pi over 5, and this would be feet. Any questions at all? Good? Okay. So let's look at number 8. The central angle theta, so theta in a circle of a radius 6 meters, has an intercepted arc length, so my arc length is 10 meters. I want to find theta in radians and in degrees, so I got to do both. Okay, so I'll start off with the arc length, which is 10. That equals the radius, which is 6, times theta. So to get theta by itself, divide by 6, so I'll get 10 over 6 equals theta, which means theta equals 5/3 radians. So what might you think looks a little weird here? there's no pi, okay? So when we've had radians in exact form, there's been pi on there because it's part of that 2 pi. But we could talk about radians in decimals. We could talk about it in fractions without pi. That doesn't mean that it's like a different type of radian with no pi. That just means the pi is already multiplied in it, and we just don't see the symbol, okay? Most of what we do when we're looking at an exact form is going to have a pi in it, but when you find something like this, you go the other way, you may end up with no pi, and that's okay. So this is my answer. I mean, it is cause for concern and for you to double check things like, oh, did I drop it off somewhere, or am I really supposed to have it? But we did it right. So then I also have to have it in degrees. So I'm going to take those radians, which is 5/3 radians, and to get it into degrees, I multiply by 180 over pi. So 3 goes into 3 once, and 180 60 times, so I get 5 times 60, and I get theta equals 300 over pi degrees. So let's talk about that answer a little bit. Is pi a rational number or an irrational number? Irrational number. Because remember, to be a rational number, you have to be able to be written as a fraction with whole number numerator and denominator. So like 0.5 is a decimal, but it's a rational number because I can make it 1 over 2. Pi is not a rational number because I can't make it into any kind of fraction. So that means I have an irrational denominator, which I have at least said to you over and over again, that's illegal. We have to rationalize that denominator. Well, guess what? You can't rationalize the denominator when pi's in there, so you can't do anything about it. So the rules really rationalize whenever you can. If pi's in the denominator or another irrational number like that, like e or something, then you can't do anything with it, and it is what it is. Okay? What questions do you have? Anything? All right, so I want to remind you that if you are going to do the test corrections, they're due today by 11:59, and I think that's all I have left for you. So if you are on Zoom and you don't have any questions for me, then you are welcome to go ahead and log off for today. And the rest of you, if you don't have any questions for me, yes, let me all right, let me go get my passes real quick. Corey, are you staying today after school? Okay.